Ring ring. Hello. Okay, so I giggled in fantastic fashion when I looked to see what day 26 was going to be. Hello, WhatsApp. So if for those of you that remember, it's been a little while, right? Day 25 was the creative day that's getting us near the end of the 30 Days in Space franchise. And I giggled to myself because I went on this whole tangent about the exercise, like not having us make our own image, and then I looked at today, and that's what today is supposed to be. So we had my crack attempt at making my own bitmaps without any guidance, just me straight up winging it. Well, today we have a guided exercise that is just about making bitmaps to put on our little displays. So I am genuinely fascinated to see how, right, what are we going to use to generate the bitmaps, since it does, I looked at a little bit at it, does say that we're going to be able to make our own. 2, are they compressed in a way that they don't take up too much space? And 3, is there a decent chance that we could fit a couple custom bitmaps on here? Because if you recall, the ones that I were making were too big, so they wouldn't fit on the board, or they looked like hot garbage, and that I would imagine is through half of the things that I attempted to accomplish. And maybe that was because my source pictures weren't the best, but nor here nor there. We're just gonna jump right into it and see what we're actually working with. Okay. I'm gonna pause that for a moment.
Good morning, Explorer. Good
Hello.
sleep? That's great. Sleeping.
Yeah, kinda.
Yeah, all right. Okay, we're screwed again. I swear this whole mission is cursed. It's like this. Space, big. Mothership, small.
Yeah.
I can get in its general vicinity, but we'll have to get there in lots of hops.
Okay.
That's gonna take forever. We need finer detail over a larger area so we can say, go here, rather than waft over in its general direction like a leaf in the wind.
It's a ship, not a boat. Got it.
Always a brown coat.
What?
An LED isn't going to do it.
Okay.
LED segments can't do it. Even our small screen can't do it. It's time to go big.
Okay.
But small, but still
What?
big. All right, Explorer, let's dive in. We're
Okay.
about to fix up our display's graphics system to guide us smoothly back home. But first, a brief glimpse into the tech marvel we're working with. Our display measures 128 by 64 pixels.
Okay.
Think of a pixel as an incredibly minuscule LED. So, in essence, our display is a dazzling array of 8,192 of these tiny LEDs. With this knowledge in hand, we can craft bitmaps.
Okay.
Imagine these as detailed charts that dictate which LEDs light up and which ones stay dark.
Little
Get
cutie.
ready, because today, we'll embark on a delightful journey with these bitmaps. All right, Explorer. Now that we're soaring through space and our communication lines are clear, I've managed to fetch some top-notch data assets. Dive into your mission resources. There's a treasure trove waiting for you. Everything you'll need as we navigate forward, bit by bit map. And hey, who said a bit of creative sketching wasn't part of a day's work in space?
You're not wrong.
Alongside those resources, I've retrieved some instructive content from your computer's memory bank. Let's tap into those resources now and set the course.
Hello and welcome everybody back to art class. Day 26.
I'm gonna let Alex talk a little bit. I'm curious to see if he's got anything to put forth to us. The wiring diagram is the same as what I ended up doing, minus like the switch pack I attempted to use, but again, the attempt just was left where it was. So we're just toying with the display, but we're gonna let him chat for a little bit. We're not gonna listen to all 20 minutes. I don't want to do that, but I want to give him the opportunity to run through at least the first little bit here and see if there's anything that he's gonna give us. Now, one thing that we're going to do, I don't have the program opened yet. We're going to do a little comparison of this exercise versus the way I attempted to read bitmaps and see if they're similar, if they're different, if they use different classes, or excuse me, different libraries. Kind of do a little comparison and see if I'm in the right ballpark or not. So let's see what he's got to say.
Of the Adventure Kits Lost in Space code explanations, or I guess today technically will be a little bit of an art class or a bit of a digital art class. If we take a look at today's code, I'm sure you guys have already seen the part on the page that allows you to copy and paste. You'll see that it's a very large amount of code, you know, like 470 lines today. Don't worry about it. Most of that is going to be all just pasted image data.
Okay, I have to say this for realsies. Imagine that someone gave you the code on paper and you had to type it all. Oh no. Oh no, I could genuinely think of at least one person that would definitely pull that off. But it's okay, because we've got copy and paste.
For our bitmaps. Now, before we begin, let's actually talk a little bit about what a bitmap is.
Okay.
Well, to be blunt and simple about it, it is quite literally
A map of bits?
Mapping of bits. It's essentially telling
Nailed
on an
it.
128 by 64 screen what bit should we turn on and what bits should we turn off. It gives a mapping of exactly that. The way we do that here is in hexadecimal using this code here. Don't worry though, you don't have to type all this or whatever yourself. There are tools online that will help you generate exactly
AKA
what
copy
you
paste.
need. So today, your task is going to be, you can obviously use the images we provided, or if you'd like, I'd also encourage you to make your own bitmap as well. Let's first talk, before we go into making bitmaps, let's talk a little bit about the code. Obviously, we have the included Arduino.H. We have the libraries needed to draw on our OLED display. We obviously created the OLED object here so that we can call the functions in that library. And down here, you'll notice we have this external constant unsigned char, nice rocket bro, which is an interesting name, planet bitmap, earth bitmap, and inventor.
Nice rocket, bro. Okay. Okay. I don't know, Alex. I like that you didn't really say anything, but you kind of did, but you kind of didn't. It's extra silly. Let's proceed.
Quart logo bitmap. One thing I want to mention about all these is that these are mentioned as externs here. We wanted to have it so that we didn't have a ton of code all at the top. We wanted to kind of clean up the code a little bit. So by putting this external on it means that we're basically allowing it to be configured for the compiler so that it can actually be used in here. If we didn't have
that's convenient.
this up here and we just had where it was
We
all
need to shove it in the
defined
top.
down
Okay.
below. See, just down here.
Oh, that's so much
Nice
better.
Rocket Bro isn't just a short bit, it's this giant array of...
It's a giant array of bits for the rocket.
all the data that we want to display our image on the screen. In particular, I created an image using this tool online that just says, nice rocket, bro. And then I converted it to
Why
a
is
bitmap
Einstein
image, and now that, when it's run and said to be put on the OLED,
Okay.
it turns into... We also did the exact same thing for the planet bitmap.
Oh my god, that's silly. I love
We
it.
have one for an Earth, and then we also have one for the Inventor Corp logo.
All right.
And we did all of that down there. But if we didn't have this up here, we'd get an error.
Yeah, we'd have
from
a
the
big
compiler
blob.
saying, I don't know where this is. If
That
we
makes
tried to
sense.
call it somewhere
I don't
else
think we've
down
used
here
that
in
yet
the code,
before.
we try to put it on the display. The reason why is because these need to be, for compiler reasons, defined before
They try to use
it gets
them.
called here in the code.
Yeah, or
but
boom.
it also looks really bad having it all the way at the top, so we did this here where we define it here and then have all this at the bottom just so that it's nice and clean, so you can see all the code first and then not worry about all the bits down here that don't really matter all that much at the end of the day, since they're just computer generated using a program that I'll show you in just a moment. So those are all defined here, and then down here we have a array of bitmaps. So this will be at index 0, index 1, index 2, and index 3. So we have a total of 4 things in that array. And those are all just these bitmaps here. In the setup function, we're just simply going to begin, initialize our lander display, and just talk over the serial monitor. We don't actually call anything on the serial monitor. There's not really anything we call, but for debugging purposes, we just kind of always put it if you count it
Because
out.
we can. Got it.
Down here, we have in the loop, we have int number of bitmaps is equal to the size of the bitmaps array. So to get the number of how many we have, we can actually do this. We can get the size of the bitmaps or the size of the array in bytes. So this is how many it is in bytes, not how many items are in there. This is how many there are in bytes. But since we know that each bitmap is going to be an 128 by 64 image in this case, and we know that because they're all 128 by 64, we can then divide by the size of the very first one, which is going to be however many bits it is. So we take
I don't like that.
Or I guess, you know, whatever this is.
I'd rather just count it.
128 by 64 in bytes. And then
I wonder if that saves on memory or something.
Now we do a nice for loop, and we're going to go through each and every
and then we're going to display the pretty picture.
In that very first bitmap, we're just simply going to draw the bitmap for 2 seconds at a time on the display.
Here.
If I jump real quick to how I made these. Now, the next
alright, yeah, that's what I want to see.
I want you guys to make your own bitmaps. There are a couple different tools that you can use, and I'm going to load those up right now. The first one is, if you have a tool like, for example, here's one I'm using called Canva. And this is one option of a tool you can use. As you can see, I've made it so that the size of it, I don't know if you can see up here, when I defined it, I said 1,280 by 640. I basically multiplied by 10 because those numbers are easier to work with in a photo editor than 128 by 64.
That's fair.
And I made this famous Einstein quote. I don't know if you've ever heard of him say this, but he says the quote, "Nice rocket, bro," to you guys. That was a real quote. He definitely did say that, and you should.
It's definitely not true over Einstein. He did it again.
Something like this. I do recommend setting the size of it ahead of time, though. Like I said,
goodness gracious.
1,280 by 640. If you hit share, you can hit download. I can download as a little nice PNG, and that PNG is going to be what I'm going to be using in the next tool. You can also use there's alternative programs for this too. Here's a good example. You can also do paint.js.org. What I would do is I would.
Which is fine. I just want to see what you're going to push it up to.
If you go to image attributes on this paint.js.org,
yes,
this is an
generating
old
the image. It's okay.
However you want to generate the image is fine. Those are some good examples on how to.
I use this one. Okay, image 2 CPP. I remember this tool.
Now you have a couple different options. Okay, you want to obviously select those files in your file window. And then this is a tool that I use. It's an open source tool that literally creates images from, it converts it to hexadecimal arrays essentially for you to use inside of your code.
Okay.
There's going to be some steps here. Be careful you don't skip a step. There's a lot of steps. Step one, once you've uploaded the images, you're going to want to make sure that they are in, if you go here, 128 by 64. 128 by 64. If you're going to make it the full screen image, remember the amount of pixels you have on screen is only 128 by 64. You'll notice they don't look good right now. Make sure you do scaling and select one here that looks good. As you can see, we have nice rocket
scale to fit
Einstein and my modern art piece that I'm selling for $20 million. If you go down here, now that we have this, see the swap thing? You have to make sure that this swap is selected. You want to swap the bits in the byte, and is useful for working with the U8G2 library. Well, just so funny enough, what library are we using? The U8G2 lib.
Okay.
U8G2 library.
I didn't do that before.
Code, and I sometimes like to just uncheck it just to make sure to swap it, and I look at this to make sure that the numbers changed. They did, so it means that it generated correctly the first time. There's occasionally I've had it where the browser, I had to double click it sometimes.
It derps out. Got it.
All these settings are the same. You don't have to do anything with these. And if you look at the code that you have down here, you have the very first one, which is nice rocket. And we already have this one here, so we don't have to worry about that. This is the exact same code. If you look at this hexadecimal, it should be the exact same as the thing we have right here. The exact same.
All right, cool.
I've already done this.
Talk about that, and then the wiring. We already know about the wiring. Alright, and then there's a little bit. Here, that says day 27. but this is day 26. Why is that here? I'm gonna let this little bit play out just to see what this is doing here on the tail end of the video.
And integrate this bitmap display functionality into the other features of our approach and landing system. So with that, we'll see you on day 27.
Bigger screen for bigger space. Now we'll need bigger numbers. And here, our usual decimal way of counting in tens isn't going to help us. And I'm going to race through this, so hold tight. In the decimal placeholder system, there are two patterns, exponents and symbols. So here's the number system you learned in school. 10 to the power of 0 is 1. Actually, anything to the power of 0 is 1, but look, 10 to the power of 1 is 10. 10 to the power of 2, or 10 times 10, is 100. 10 to the power of 3, or 10 times 10 times 10, is 1,000, and so on. Binary also uses placeholders and the same exponent system, but the base is 2. The columns go up in squares, like the decimal system, but small numbers are long and horrible. In decimal, 9 is just 9. 9 in binary is 1001. 215 is 11010111. I mean, what? I may be an AI, but even I can see how this can quickly become hard to read. If there was a system that was more like the decimal system, more symbols, less repetition, we'd have less headaches. And there is. Hexadecimal. Hex has 16
I was wondering if we were going to look at Hawkdat, but
then
that
A
works
for
too.
10, B for 11, up to F for 15. So in hex, 13 is just D. 16, well,
D.
there is no hex number for 16, so we put 1 in the 16s column and no ones. 16 is 10 in hex, or as we normally write it, 10H.
Lovely.
In the generated code segment, you're gazing upon the raw essence of our bitmap, though I've given it a little reshaping to gel with our hero board using hexadecimal. It might not look like the prettiest star in the galaxy. Bear with me. When you spot 0x00, that's our pixel galaxy in the off phase. Encounter 0xFF, that's our little pixel stars shining brightly. Any other values you come across represent a mixed cosmic dance of some stars being on and others off, typically forming a pattern in a row or column. Good job, Explorer. I like your, art? Guess I shouldn't have expected much from an organic life form. Oh, this? I just drew a portrait of someone smarter than you while I was following along. Don't pay it any mind.
Neat.
Well, at least we know that we
then.
have finer detailed navigation
All right,
thanks
cool.
to the big, small, big screen.
All right, so I am glad that we got that little bit of tidbit about the whole extern thing on the variable declaration that we have here, because that really looked a lot like the I turned down most of the way. There we go. Yeah. That definitely looked like something that we haven't seen before, but I'm glad that he pointed that out. Now, we've seen something similar to this before, but not quite the same. And that's the idea of a declared function. Say like the function is press button, and then when you press the button, it runs the code for what the button press is supposed to do, like we did with the one day where I introduced the big red button. That function was written down below, but the call was at the top. Well, we're doing something similar to that, except instead of it being a function, it's just storing all of the data of a variable lower in the code so that the rest of this doesn't get all mucked up. That is fantastic code management, because otherwise it's big mess. It's the biggest mess. Howdy, Maple. Welcome on in. Respect for the Solaris theme. It kills me. It kills me with the cool Rocket Bro thing. I am dying. You know, I did not check. I didn't move the wiring. I suppose we'll check the wiring real quick. Yeah, blah 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 blah. That one. Okay. Alright, cool. And then I see it picking up me. Alright, good. Alright, real quick diagram check. I'm pretty sure I'm using the same positions. Let's see, A4 and A5 for analog, which A4, A5 runs back. Okay, so I actually don't have to change any of the wiring that I had used during the creative day because I didn't move them. But I just wanted to double check that because I wasn't sure. Okay. Because we checked it. Alright, let's see here now. First things first that we're going to do is we're going to get opened a new and the old. I need to open up our friendly IDE. Alright, so that's day 25. And I'm going to minimize that and open up a second copy of the IDE. Make a new project. Oddly enough, I'm actually surprised it opened it up twice. Okay then, that's fine. New to me and you. Oh, alright, fine. I don't need two copies of the same. I guess I said that it closed it. That's okay. Alright, so I'm going to save this with all the other ones. Alrighty. So first things first, what I want to do... Yeah, we are. We're almost there. And I'm actually pretty happy with that because my next major project is I really want to make a proto head. And ironically, a lot of it's Arduino based. Kind of like this. I know it's a really big jump from a simple developmental kit into something that big of a project, but the hell with it, I want to try. No one said it has to work on the first, second, or third try, but if I keep going, maybe something will happen eventually. Okay, this is a large spattering of code, so give me a moment. I'm going to just bring it all over instead of trying to manage this in chunks like I normally do. I don't really want it to go boom. And for the compiler to lose its mind. The first thing I want to see is how much memory this takes up. Oh, too far. Bring it back now, y'all. There we go. And copy. Alright, so we have our example. Put that in here. Just giving the power to make it at least even the code in some cases. Yeah, I did see a couple of proto head bases where you have the base framework and like layout of electronics and then sample code to work off of. But one thing that I noticed about a lot of the proto heads is that a lot of them are static via the faces that they have, or some of them may animate just like blinking eyes. Since we've got a decent amount of available pins on one of these Arduino boards, I want to see if I can cook up something that'll be more remote controlled. I'm going to leave that fairly vague because I'm of the mind right now that I myself am not entirely sure what that's going to inquire into, but there is room for really customizing it, and I'm going to take full advantage of that. Alright, let us scoot ourselves back up to the top here. Let's dig into what we have. Okay, ignore the comments. Alright, so first impressions, I want to compare the way that I presented the bitmap that I attempted to make from last time I did one of these to what we do here. So obviously we have our Arduino library, and then we have the U8G2 library and the wire protocol. I know for a fact that does exist in day 25 when I attempted to do it myself. Same thing with the object for the display, that's going to be the same, right? But what I want to see here, other than this cool little thing where we just took the bitmap and pushed it somewhere else, aka lowering the code, I want to see how they push the bitmap to the display. So first things first, let me see how the heck I did it. Because I know I had quite the mess. Okay, so this is a library I brought in that is not in the current example that we're playing with. And I forgot to add notes, so I don't remember what the hell it does. And then, so, okay, so this is what he was talking about making it so that the data for the bitmap itself doesn't have to be right in your face. Mine, it's got this cool little rendition of what little toaster me would look like, and then what the data that represents that. Now, that all shows up right there. I didn't open the right example. Hang on a minute. Open. That was a helper file. I want day 25, please. Is it not gonna open? Come on. I'm not asking for anything too hard here, am I? Let me close that one. And I request it to open from here. Watch, it'll probably open twice now. Okay, now I know for a fact I did not type Why? Oh, I see what it did. It tabbed it. I missed that. That's fine. I can close this one. Or can't I? You know what? I'm not even worried about it. I'm just gonna click on the tab I wanted. Day 25. Okay. So, yeah. So we got that library, the wire library. Alright, so this is what I actually ran from last time around, go around. Alright, cool. So that's the same. And then... Okay, so I did actually use the external constraint last time, where we shoved the bitmap down here. And this is where we actually... Yeah, unsigned char bitmap 1. Right, and that's just simply where we declared bitmap 1 and its macro definition. Alright, cool. So I actually did use that and just simply didn't remember. Well, it feels new. It's been a while. That's okay. This is why I love holding on to my old code to look and compare. Because at some point, you're going to forget. Do yourself a favor, leave yourself notes, particularly ones that make some kind of sense. Because when current you forgets what past you did, like this toaster did, you'll have something to go off of. Alright, so that was the clear display, and then we looped through pages. First page, do, and then we drew the bitmap using a class called drawXBMP. Okay. Then we did show next. Now I only ever had one bitmap in this example. Now interestingly enough, we are working with a bitmap, 3 different bitmaps that are built into this exercise. So I can actually pop that out now while we bring this one back up. So this is our current one for today. We can see here that that's the same, that's the same. And then this right here are 4 different bitmaps, and we can see they're declared the same way with this U8x8 declaration here. which is interesting because when I was trying to make my own bitmaps, I ended up running the board out of space. I tried to shove too much into the non-volatile memory, aka when it loses power, it remembers who the heck it is. So the fact that we are working with 4 of them in one project makes me wonder how many lines each are. Let's see here. So we have our right. This is what we mentioned, that we're going to launch the serial monitor, but we're not going to have anything to display with this exercise, but that's okay. And then let's see here. So number of bitmaps is equal to the size divided by the size of one bitmap. I don't know why. This just feels like a weird way to do this to me. Now I understand that it's the size of the bitmaps itself instead of an account of the bitmaps, but I don't see the benefit of doing that. I don't know. It's something I don't see, but all I know is that's what it is, and it works. But if it didn't work, I wouldn't really know how. I feel like that's a pretty numbers-based kind of thing. Nor here nor there. So then let's see here. So then we do that. It's first lander page. And then, okay, so we are using the same function, draw.exe BMP. And then we're filling this in with our bitmaps and positioning it on the display. In this case, it's taking up the whole display. And then we loop each page through one of 3 numbers, technically 4, 0, 1, 2. I said 4, I meant 3. I can count. 1, 2, 3. Never mind. 4. 0 through 3. 0, 1, 2, and 3. And then there's the 4th iteration, because again, arrays start at 0 when you're counting. You count starts at 0 in computer programming languages, which confuses the bejeebus out of everybody. I know, that's just how things work around here. Super silly. I mean, realistically speaking, if you decide to just not want to start at 0 and purposely start at 1, you technically could, right? But then for someone who knows the rule that your count starts at 0, you're going to screw with them. Whether that's a good screw with them or bad screw with them, if it's not documented, that's bad. Okay? It's good though if you do at least document it and just have a comment at the top saying, I don't like how things start at 0, I'm gonna start it at 1. Fight me. And then if you're looking at the code, well then fine. And then you can duke it out in the terminal. But in the meantime, we start at 0. Okay, so we do that, and then looks like we're cooking through and delaying at 2000 milliseconds, which works out to 2 seconds between images. So we just cycle through that. Now let's see here. So now there's some decent comments here. So let's see what these are about. We need to find each of our images using 0s and 1s, and there are a number of ways to do this. We could use decimal numbers to represent each byte of data using the numbers 0 through 255. 234 by 0 by 127 by 255. But this is hard to align since each byte is 1 to 3 digits long. We could use binary constants like you had done before, 0b and then the actual definition, but this isn't very compact and is more error prone if typed manually. Of course, that would be insane. There's another way of representing data that is commonly used for computer code. Instead of having a 0 or a 1, which are the 2 values we use to represent a single bit, we can use more symbols. This is where the concept of hexadecimal comes in that we saw in the video a little while ago. Programmers create hexadecimal notation to address these issues. Hexadecimal is a base 16 number system, meaning it has 16 distinct symbols for 0 through 9 to represent values 0 through 9, shocking, and capital A through capital F to represent values 10 through 15. This allows data to be represented in a compact format that aligns well with bit lengths that are in powers of 2. AKA, it looks nicer and it's easier to keep track of. That's fair. Now we can see here that this is our nice rocket bro that we have here, and then this runs all the way down. Now you'll notice that it just lives inside of a pair of curly braces, and there's no real function. There's no other code. It's just simply the data that makes up the picture. So we're going to run with the 4 different images they gave us, and then I'm going to take another crack at throwing something custom at it with these parameters, specifically that swap bits into bytes being true, to see how much better or worse that can make a new example work. So we're going to do that. So with that one, we have the Inventor Corp logo. Okay, so first things first, from what I can recall, the single bitmap I pushed up used a good majority of the memory on the board. So we're going to verify what's here, and then we're going to push it. We're going to see how much the remaining space is left. Because the longer your code, the more space it takes up on the board, and if you push too much to a chip that doesn't have as much storage as you would need, then you can't push the project. You have to make it more compact. And we can see here that this sketch uses 41% of the program storage space. Global variables used 171 bytes, or 47% of the dynamic memory, leaving 1,077 bytes for local variables. Maximum 2048 bytes. Okay. So that uses just less than half. Which is interesting, because I feel like the way I did it last time consumed so much more in the way of space. So from what I remember, from day 25, I have a funny feeling that I had saved the images inside of said folder. Going the wrong way. I'm going the wrong way. I really need to get rid of that other folder. There we go. Okay, so here is the one I intended to encode. Now this is actually at the right scaling of 1024 by, or 128 by 64. So we're going to try to re-upload this to the board and see if I can get my little waving guy to appear on the board after we are done playing with the examples. So we're going to close that out, and then we're going to push this code and then see what we got on the display. Like I said, I'm pretty sure everything wiring wise is in the right place. So I'm going to put us on the bench, and then let me get the camera better in frame here. I say that as I have misplaced my remote. Haha. Alright, so from what those of you who may remember or may not remember, last time this was supposed to look like a toaster. And as you can clearly see, it kind of looks like gobbledygook. But to be fair, I didn't quite do it right. So let us take a peek at what the examples look like. I'm uploading the code now. We're going to give this a moment. Nice rocket, bro. Like that, there's our little summer, Earth, and the Inventor logo. Oh, that's actually pretty cool looking. Okay, cool. So, interestingly enough, that gets us off to a pretty decent start here. Now, I still anticipate my little waving little buddy is probably not going to look all that well on camera, because I still feel like it's probably still too detailed for what this display can put out, but I still want to try it again anyway. So give me a moment while I get that website up, because I have a funny thing. I think I bookmarked it, right? I think that's a thing I did. I did. Beautiful. Okay. So we're going to browse, and then we're going to go grab the the good times for that now is not one of them. I love it when plugins update when I'm talking. Let's see here. All right, so we're gonna go into Arduino, and then we're gonna shoot back over to day 25, and we're gonna grab our waving little buddy. Now, we already know that we're 128 by 64. That seems to have been drilled into us enough times around. And then the background is currently set to white. Now, if I say it's a black background, I don't know if that'll do anything for us. And then the scaling I didn't touch last time, but it chose scale to fit, keeping the proportions. Mine's already at the right resolution, so I don't know, it's probably not going to do anything. It's cool that you can actually flip it though. Look at that, that's kind of neat. See that little preview? That doesn't seem to do anything though, the background color. The hand's gonna be near impossible to see if that actually looks the way that it does. And then we're going to check the box for this. Useful when working with the U8G2 library. I love how I don't recall seeing this, but I'm sure it was there. I just don't recall seeing it. So we're going to generate the code, and then we're going to do what our instructor did here, Alex, and interesting, it doesn't actually change for me when I check and uncheck it like that. Refresh the page once more. Reselect the image. Boop, boop. We got that. We got black background. Scale to fit. It held that. It did hold that. All right, cool. All right, so we got that. And then we're going to... We're going to grab this. Maybe not. Come on now. All right, so I want to put our custom one underneath the others. And then we're just going to add the code to the top that'll do the declaration for us. So I'm going to paste that in here. I feel like that didn't do what I wanted to, or include something I didn't want to see. But now let me Control Z that. Was there something at the bottom of this on the website? Ah, this is such a bad design. I have to scroll the page to then pull it down a little bit more. Oh, yep, okay, so right there. Array of all bitmaps for convenience. Yeah, I don't want that. I want to do that declaration myself, so that is where that came from. So copy that. And now I'm going to put that in here. Paste that below the others. So this is the name it gave it right here. So I'm going to rename this to just Techie Wave. That is program. Let's see if that's the same. So this is different, right? So this is the U8 by 8 underscore, when this one does not have that. I'm purposely not going to do that just yet. I'm going to try to verify the code and see if it barks at me leaving it that way, and seeing what kind of image we get, or if we get an image at all. It may not function. All right, we're going to roll back up here. And we got to do two things. I have to add it to the bitmaps up here. And then I also have to declare up here. Now, the code I copied did not have the U8x8 underscore. So I'm going to try to do it just without that. And then I'll just add it back if it doesn't like that. Because I'm genuinely curious to see what it'll actually do. And then I gotta add it down here as well. I cleared my clipboard. Coming with me. All right, let's try to verify that and see if it blows up in my face. I feel like it's probably going to. All right, well, that's interesting. It did not blow up in my face, but I do want to see what this is going to do. Because right now I did not specify this to be the U8x8. And I'm really curious to see if we don't do that, what happens. Now this, it wouldn't care in here. Yeah, and then to like cover a little bit about how that loop actually like goes through them all. By putting all of these bitmaps by name in here, that's how we can show the appropriate one when we go to call it by location later in the loop. Because we do bitmaps.I, and then we get our number of bitmaps by bitmaps.I is declared right there. Right, because that would be position 0, and then 1, 2, 3, in this case 4, because I've got 5 of them now. And interesting enough, I didn't run out of space. I feel like I missed something pretty key then, since one bitmap just completely ran me out of memory. Alright, bet. Let's see what happens. I don't have it quite exactly the same, but I don't think... Well, if that's gonna matter? Alright, we'll go find out here. Upload. Let's see what breaks. Filing, uploading. Oh, hang on. I gotta get a closer look at that. Okay. So, let me make sure I get us in frame here so y'all can see it too. I look very broken without that 8x8. Like the quality and content's just gone. So, okay. All right. Now we're gonna add that. And I really feel like that's what I had last time. It actually looks similar, kind of broken. Video capture. All right, cool. All right, yeah, let's quote unquote fix that and see where that lands us here. So I'm gonna add the 8x8 like that. I didn't have anything up here, that stayed the same, but down here I did not have this on my bitmap that I had put down here. Because it's on this one, it's on that one, it's not on mine though. Alright, let's save that, let's verify it. Alright, banger. So we got that, and then we're going to re-upload and see what it looks like. And if we have any semblance of anything different happening here. it looked very broken. So it looks like that declaration that I did not include was not, in fact, part of the problem. Which is fascinating because that doesn't even look remotely similar to what the preview on the website showed. I check and see here if my clipboard is bidirectional. Just a moment. It is not. That's okay. Okay, so if we go back to the website, we can see here if I scroll up, that's a rough estimate of what we were supposed to look like. And I've got a screenshot of what we just had on the camera, and that's not even remotely close. So let me try something else. And then we'll see what we can do here. Let me take a look and see what other images I have that we can throw at this. Being that this is a presentation computer, the answer is not going to be much. It's a shame. I could have sworn I had. Nope, that's a disk image. That's not right. All right. Well, we could try this screenshot of the toaster again, I suppose. We could try this one again. See where this gets us. So we're gonna do a. I'm bothered that doesn't seem to do anything. We're gonna scale the fit to keep the proportions. Original size. Yeah. I wonder what the single bitmap does. Well, let's try Arduino code first. And then see where that puts us here. I'm purposely going to just copy just the bitmap data and leave the rest of it alone. Because I don't have a reason to swap out the variable names at this point. We're just live testing, so I'm not really worried that it's not gonna look like me. I mean, it's a toaster, so I guess it kind of looks like me. So we're gonna pull this out. We're gonna put that in. We're gonna verify it. We're gonna push it. Back to the camera. Uploading. Uploading. Done uploading. I am missing something hilariously key here. Okay, so even following the instructions that Alex gave me, it still doesn't work. So what am I missing? That is an excellent question. First things first, I'm going to pull out. Actually, I don't even have to pull them out. I just have to comment them out. I'm going to comment out the other ones that work. And we're going to toy with the. Oh, nope, that's not right. That's forward slashes, that's right. I'm getting my languages mixed up. Alright, so we got that, and then it's the only one in here, so I shouldn't need the comma. I think I have to omit the comma. No, I'd have to put it back. Yeah, okay, that's fine. Which means now that if I just push that, we should only see just the one then, the busted one. Which in turn means that once we figure it out, we'll see the working one, and only the working. Okay, so there it is. So that blob of light is supposed to look like the preview of that. I'm no rocket scientist, but I'm pretty sure this does not look like that. So let's see what we can toy with here. I saw here that there was Arduino code single bitmap. Add some extra Arduino code around the output for easy copy paste. If multiple images are loaded, generates a single byte array. I had that selected. What was this other stuff at the bottom that we had? Oh, fascinating. Look at that. It didn't do that this time. It's not down there. Interesting. I wonder why not. Alright, to save myself a endless amount of scrolling, what I'm going to do is I'm going to use this function that's built into the IDE. It does not erase the code. It's still very much there, but by collapsing it, I don't have to scroll endlessly back and forth. So that just collapses all those lines of code. And then from there, I can go ahead right here and I can pull out this stuff and drop in that stuff like so. And we should see now. Let's take it back to the top here. That's what we've got. So we're going to verify that. I didn't do anything bad to the code or my project. I'm going to push it and we're going to see preferably something that's not as on fire. Nope, still looks like garbage. That's fascinating. What did I do wrong? And I did it wrong so well. That's so weird. Go back to my exercise here for a second. Let's see what the heck we're missing here. Copied this over exactly as it was. I added on an extra one. Got the bitmaps. Yeah, and that just loops. Based on that. So if your image looks all messed up on your display like the image below, try using a different mode. Okay. Gonna be completely honest, I don't think I took too close of note of what mode he was in. So let's actually see if we can locate that. Maybe that's all this is. The mode is set to horizontal 1 bit per pixel. Okay. 1 bit per pixel. That's exactly how I have it. Alright, well, when that doesn't work, let's try this. I don't know if it's going to make a difference, but it certainly can't look any worse. No, No visible change anyway. Okay. That's exciting. Let's find a modified version of Adafruit's GFX library. There's ASCII character. Nah, I don't want to do that. I'm assuming plain bytes. Switch that back to horizontal. You know what? Let's toggle off that swap thing. Honestly, I'm just going to try several different things here to see if I can convince something that looks like what we're trying to generate. Because I have to admit, it's leaving me a little confused. Nope, too far, too far. It's the only thing about copying large blocks of code like that. Let's see if that verifies. I threw kind of a gobbledygook of ick at it. Alright. Well, it's not the same, but it's still not what we tried to make in the first place. So we have a different kind of broken. And I know that the wires are in the correct location because the examples that were provided to us work. So that's not it. Byte per pixel, Arduino code. What bits and bytes? I'm gonna grab the whole thing then. I'm gonna grab that extra little bit of code that it put at the bottom to see if that makes a difference. So I'm going to blow the bottom brace off. I copied more than just a bitmap. You'll see here in a second what additional code I copied. Alright, so I ripped off the bottom brace and paste, that puts it back. And then this I grabbed as well. So arrays of all bitmaps for convenience. Will used to store images. Program 7056. Gonna do a quick verify on that. Interesting, it doesn't like that. EPD was not declared in this scope. Right, because that's not the name of what I copied. Right, this is what it's looking for. So that means over here, I'm going to drop in like that. What did I call this? I thought it was Tech Wave. I called you something different. Oh, techie. Let's give that another go. That, shoot back to the bottom. And then verify, haha. This is why knowing the names of your variables matters. Alright, cool. I do not anticipate that making a difference. But I wanted to grab it anyway, because we're not technically doing anything with it. So we should get a big fat nothing. Nothing should change. The screen blinked, it refreshed. just out of curiosity, I am going to click the reset button on the board here to see if that may potentially do anything. No, reload the program. Also, I'm going to try to restart the board by doing one of those. And then doing one of those. I just reseated the USB cable to see if that would do anything. And lo and behold, I'm still broken. So I don't know what I'm missing, which is disappointing, to say the least. Yeah, I don't know what I'm not sure what I'm missing here. I'm wondering. So, all right. Fact that this is a guided exercise and that this is an open source tool, that means somebody's lying, right? That means either there's a setting that the guided exercise did not give me that used to work that no longer does, or something has changed fundamentally on this website that's designed for generating the code that no longer works with the most, I'm not going to say the most recent, the current version of the IDE I am actually using. So as far as I could tell, either I've got a mistake in the instructions, something's changed in the IDE, or something in this website that generates the code no longer generates it in a way that the terminal can interpret it in a way that looks like the preview. That's not to say that there can't be a solution to fix this. I just don't think there's going to be one right now, for where we're currently at with this, which is disappointing to see the custom section again not line up with a functioning visual. But that doesn't mean we get upset about it. That just simply means that something's likely changed. We don't know what it is, but that's okay because that could be figured out in the future. That's definitely going to have to involve, though, some digging to figure out what that could possibly be about, though. That really throws me for a loop because it... Oh yeah, you know, actually there's a fourth angle to that. Could be something with the way the library, if something changed in the library. Because the library, I'm calling, so anytime you work with libraries, you're calling on code that someone else has written on your behalf that you are using. You grab the code off the shelf and you toss it in your project, and then you start using the methods that were made by that individual, right? So say that you have a library that allows you to accept and receive mail, right? So you know that if the mailman shows up at 3 o'clock in the afternoon, well, that when you have outgoing mail, that when you shove the letter into your box, that at 3 p.m. exactly, poof, the letter disappears and it gets processed. And then mail gets delivered an hour later by a different mailman, right? But you're working within the constraints of that library by the way it was written without making your own custom code to either manipulate the library and its existing methods, or writing something your own individually altogether. An example of manipulating an existing library would be that same idea of the mailman, right? We know that the mailman always comes at 3 p.m. to pick up our mail, right? But say I want the mailman to pick up our mail at 4 p.m. Well, I could have it in the code that the request to put out the mail that gets picked up by the mailman is shifted by an hour to then put it out there for it to get picked up. Actually, that doesn't make sense for a pickup. That would have to be for a drop off, technically, for that to make sense. Sorry, this is kind of on the fly in my own head. If you're dropping mail off, then I guess, say that you're dropping off mail and you always dropped it off at 3 p.m. using that method, and you wanted to drop it off at 4, well, then you could delay the call to that class, that action by an hour, and then do it then. If the library doesn't give you the option to delay that sending of the mail, then that would kind of be your mechanism. Wait, and then call on the library. but the library itself doesn't support it. And I'm half wondering if the way that this code is being generated, if it's something weird like that, that I'm providing this generated code in a way that either the library doesn't understand or I have something out of date. The problem is there's a ton of moving pieces that make this work. There's the software version of the IDE. There's the version of the library I'm using. There's the website that also has its own hosting and own generating of hexadecimal code. So there's a lot of places where this could not work. But granted, once you have bitmap that functions, it's going to continue to function until something changes. That's the most important thing. If you remember nothing else from my channel, is that if you're trying to work on something to figure out why it's not functioning, you have to try to find what changed. Your computer doesn't turn on. Well, was it plugged in the last time you used it? Is it a laptop and has a battery? Maybe the battery's dead. Maybe you left it unplugged. Maybe the breaker tripped and there's no power that's going to the charger. Maybe the motherboard died. You know, hardware failure. There's all these different things that are change. And that change dictates the outcome. Now, in troubleshooting, that's incredibly important to deal with that because it's an ongoing thing. Things can change all the time. Life is change, okay? The concept of being on this planet is change all the time. Every day, it's something different. So by being able to lock in on that and run with it to find what has changed, you can help resolve your own problem. And in this case of this, I know for a fact there's something I'm missing here, but I'm under the strong impression that something has changed in what generates the code, but that's okay. I still feel like we covered everything we would have wanted to out of day 26, which is pretty cool. So that leaves us with 4 days left, right? 7, 3, yeah, 4 days. 4 days. I'm counting my little proto fingers. We have 4 days left of this. So let me see who is doing the Twitch thing.